Have you ever really stopped to think about the absolute magic that's happening inside your computer at any given second? I mean, you've got the brain, you've got the memory, the keyboard, the screen. They're all totally separate parts, but somehow they all work together in perfect harmony. How? Well, that's the big puzzle we're going to solve today.
Seriously, just think about it for a second. The processor is crunching numbers like crazy. The memory is holding on to information. Your mouse is zipping around, sending signals. It's all happening at once. They're different components made by different companies, yet they communicate flawlessly. How on earth is that even possible? That's the core question we are diving into right now.
Okay, to make this easy, let's imagine your whole computer is a big, bustling city. And in this city, we've got three main districts, right? The CPU, that's like City Hall. It's the central command, making all the big decisions. The memory, or RAM, well, that's the grand library, holding all the books and information that City Hall needs right now. And the I/O modules? Those are the ports and airports, handling all the traffic and communication with the outside world.
Now, for any city to actually work, you need roads, right? You need a way to connect City Hall to the library and the airports. In a computer, that essential road system has a name. It's called the system bus. This is the invisible infrastructure that makes everything else work. So, what exactly is a bus? The most important word here is shared. This isn't a private driveway for any one component. It's a public highway system. The CPU, the memory, the graphics card, everybody uses this same common road to send messages and data back and forth. And here's what it looks like under the hood. You can see the CPU, memory, and all the I/O devices are all physically hooked into this central bus, which is really just a set of wires running in parallel. Any part of our computer city can tap into this information superhighway to send or receive stuff. It's what connects the whole shebang. Oh, I love this visual. It just makes the whole concept click, doesn't it? You've got the processor up top, and it's sending data, these little red cars, zooming down a multi-lane highway to the memory modules at the bottom. This is literally what's happening, millions and millions of times every single second inside your machine.
So, we've got our highway. But you can't just have a highway with no rules, right? That would be total chaos. You need lanes, you need street signs, you need traffic lights. Well, a computer bus is no different. So let's talk about the rules of this digital road.
You see, the system bus isn't just one big, messy cable. It's actually a super organized bundle of many, many tiny wires. And these wires are grouped into three distinct teams. You've got the data lines, the address lines, and the control lines. And each one has a very, very specific job to do.
First up, you have the data lines. These are the actual lanes of our highway. This is what the cars, the actual bits of data, travel on. The number of lanes is called the bus width. So, a 64-bit computer, that's like having a 64-lane highway, letting it move way more traffic at once than an old 32-bit computer. More lanes means more speed. Simple as that. Then, you have the address lines. Now, these are the street signs and the building numbers of our city. They don't carry the data itself. They carry the location of the data. So, when the CPU needs a piece of info from the Grand Library, it puts the specific shelf number, the memory address, onto these lines. It's basically shouting, hey, I need the information from this exact spot. And finally, the control lines. These are the traffic cops and the stoplights of the whole operation. They manage the flow of traffic to make sure there are no collisions. For example, one component might send a bus request signal, kind of like raising its hand to say, hey, I need to use the road. Once it gets the green light, the CPU might send a memory read signal, telling the library, get that book ready to go. It's this constant coordination that keeps everything orderly. Now, here's where it gets really interesting. This whole idea of having just one main highway for the entire city, well, it creates a huge potential problem. As our city gets bigger and busier and more cars want to use the road, that single highway can get very, very crowded. It's a simple question, and you already know the answer, right? I mean, we've all been stuck in rush hour traffic. Whether it's cars on a real road or data in a computer, when too many things try to use the same path at the same time, you get a massive slowdown. And that slowdown has a name. It's called a bottleneck. If the processor, the super fast graphics card, and the hard drive are all trying to shout down the same shared bus at once, it just can't keep up. The data gets stuck in a digital traffic jam, and the performance of the entire computer just grinds to a halt. This was a huge problem for early computer designers. So how did they solve this mess? Well, you don't build a modern metropolis with just one single highway running through the middle of it. No way. You build a sophisticated, multi-level road network. And that is exactly what modern computers do. This contrast just shows the evolution perfectly. On the left, you see the old design, one single highway connecting everything. Simple, sure, but totally prone to traffic jams. But on the right, that's the modern solution. It's a much smarter, hierarchical system. It's a whole network of different buses, each one specialized for a specific job.
So let's break down this modern road network. At the very top, you have a super fast local bus. Think of this as a private expressway, an Autobahn just for the CPU and its personal assistant, the cache. Super high speed, VIP traffic only. Then you have the system bus, which is like the main artery that connects to the grand library or our main memory. And finally, you have slower expansion buses, which are like the local side streets for the less urgent traffic, like from your keyboard or mouse. This is brilliant, because it separates the fast traffic from the slow traffic, and boom, no more digital traffic jams.
So the next time you click your mouse or type a sentence or watch a video, just take a second to remember that bustling city inside your machine. It's all being powered by this incredible, invisible network of highways, expressways, and traffic signals, the humble system bus. It's the true unsung hero that turns a box of separate parts into the powerful computer you're using right now, making literally everything you do possible.